In this video, we're going to review the composition limit law. So that law says, if it has some clarifications, but if the limit as x approaches a of g of x equals k, then the limit as x approaches a of f of g of x equals the limit as x approaches k of f of x. And I think that is a little hard to parse what's going on, so I'm going to write it in a way that looks a little bit more confusing but might help you understand what's going on. One way that you could write this is that the limit as x approaches a of f of g of x, this is going to look really weird, is the limit, I'm writing limit really big, as x approaches the limit as x approaches a of g of x. And it's that limit of f of x. So what you can see is that we kind of need to start by doing the limit as x approaches a of g of x. And then that is going to be the value we're approaching when we look at f of x. And that sort of makes sense because we have some composition of functions here, so we kind of stuck a limit inside a limit, just like we stuck a function inside a function. Okay, so let's see what this looks like here. This is asking us to do the limit as x approaches, the limit as x approaches 3 of g of x is asking us to do that limit of f of x. So what is the limit as x approaches 3 of g of x? Well, if we go to our graph and we look at where x equals 3, it looks like g of x is approaching 2. So this is just going to be the limit as x approaches 2 of f of x. And what's that going to be? Well, as x approaches 2, it looks like f of x approaches 3. So our answer ends up actually being 3. So that's just a quick look at how we use that composition law again when we have graphs of functions.